So this is two-way clipper circuit. When I give a sinusoidal signal over here, there might be a positive peak and negative peak. Some portion of the positive peak is having noise. So what I do is I want to clip some portion of positive peak and negative peak. For that I will be using diode in one direction for positive peak, diode in the opposite direction for the negative peak. So there will be up to some reference of 1 volt. Above 1 volt it has to be clipped over here, and below 1 volt it has to be clipped. So that is how I do the simulation for this electronic circuit. So where I am using CAD tool called Multisim. So as usually, like we are using so many, we were like connecting so many circuits in the multisim, and we have done the simulation for the multisim. Sorry, we have done the simulation for a electronic circuit through the multisim. So now let us see the functionality of this circuit. Let us verify the functionality of the circuit. So here, if I go with the oscilloscope over here. So this is my channel A, which is connected at input. This is what channel B, which is connected at the output. So where across the input I have a total input signal sine, but there is a problem if I have like there is a some portion if I have a distortion noise and some portion has a distortion noise. So this part I have to clip, let us suppose. So this is the some portion I want to clip, and in the similar way this portion where I want to clip, so that both clipping at a positive peak and negative peak can be possible with the two-way clipper which I have designed. So the functionality of the circuit through multisim, how I have verified by connecting all the components using electronic components which are already available in the library. So if you see that this is what we call it as a library, where across which we can see all the list of electronic circuits, electronic components, where I need voltage source, where I need a diode, where I need a capacitor, where I need op amp, where I need transistors. Everything is available out here by taking all the components, instantiating all the components, and we can connect the circuit diagram. We can connect the circuit diagram, and we can do the simulation, and we can observe the functionality of the circuit. So this is a simple process where we already discussed. But now we have another method. Now we have another method. So whatever the electronic circuit which you need to be simulated, so we'll be doing the simulation, right, not through the electronic circuit which are connected virtually by the electronic components, now through the spice code which we will be generating now. So now let us know how to generate a spice code for the electronic circuit. Before that we have to know one thing, how to generate a command, spice commands for each and every electronic component. So here, here, so if I define, there will be V1 voltage source we have, and V2 voltage source we have, and V3 voltage source we have. First of all, we'll have a list of components. We'll give a list of components. We'll define the list of the components, and three voltage sources we have, and two diodes we have, D1 and D2, and there will be a resistor is also there. So there are around like six components we have. Means we have to generate a six commands, and while generating a commands we have to know few components will not have a definition. We have to keep the definition of the components. Means we have to keep a model files also. For voltage source, model files are not necessary. For the diode we have to put a model file. This is model file is required. So for this also model file is required. Model file is required, and for this also I need a model file. So what I do is, whatever the model files already defined, already we have it in the multisim, I will be using the same model files here. So for that sake, in the multisim also, not only in multisim, any electronic computer aided design tool, CAD tool, for every CAD tool there is an option given, view view spice netlist generator. So for corresponding electronic circuit how we have connected, there will be spice command also, spice code netlist viewer also will give the spice code for the corresponding circuit. So here what happening is there is a model files are provided for the diodes. This is what diode, and this is also similar kind of diode. So that's why like the model file will be provided for that. So what I do is I will be taking the same model file. So the model files will be available in the internet also. It's not required, not necessary the same model files will be used. So now let me take the same model file for this one. So I'll be copy the same model file over here. Yes, so this is what a model file for a diode. So in the similar way, so what I do is I will be copying the model file for the resistor also. This is the model file for the resistor. So which means whatever the resistor property that we have, that property will be defined across the model file. So this is the model file for the resistor. This is the model file for the resistor. So this is the model file for the resistor. So now let us generate a spice code for the rest of the components. A spice code for the rest of the components. So before generating a spice code for the rest of the components, what I do is I will be giving a notation for all the wires. So this component is connected between these two terminals. This is what a terminal we call it as input, and this is the terminal we call it as a ground. That is what my notation is. It's not necessary you have to use that same notation. Anybody can use like any notation, but we have to keep the same notations in the spice code also. So this is what my output. So means so this is the node which has the notation of I input. So all the nodes which are there in the branch up to here will have the same notation of I input. In the similar way, all the nodes in this branch also will have the notation I input. So from this point to this point, and from this point, all the nodes in the branch will be having the same notation ground. So now this is the different branch where I have to give the another notation. This is what my electrical node I will be defining with the name D1 dx, let us suppose. So this is the name I define with the d by. So in the same way, if any wire is like new, I have to give the notation for every wire. But this is wire up to here. Here it will be having the notation of I input. From here to here, it will be having the notation of output. So from here to here with the notation of ground, and this wire have the notation dx. This wire has the notation dy. Now there will be 6 electronic components, and there will be 4 wires, four electrical nodes. So totally with this one, right, we can generate a spice code. So there will be 6 electronic components, and and 4 electrical nodes. So combination of these two will be our circuit. So now what I do is I will be using my notation for the V1. So this is the V1, which is called as a source 1, voltage source 1, and writing the spice command for the V1. If you feel like a difficulty to remember that, there is another option. So we can use spice command tools, tspice tspice. Let me use that. So there a spice command tool we can open. A spice command tool I can open, and there we can generate a new spice command document. So here in this document there will be using an option like control M. We can open a command wizard. We can open a command wizard. Using command wizard, what are the commands that we wanted to generate for any source, we can generate it over here. So now we want to generate a spice command for the voltage source. So what I do is I will be I will be using a voltage source notation here, and what kind of voltage source you want to use, what kind of voltage source you want to use, that we have to mention it here. So I want to use like a voltage source sinusoidal signal, so I have to use the sinusoidal signal voltage source now. And what kind of properties we are expecting for the voltage source, we have to define it over here. So my voltage source name is, so my voltage source name is V1. So I will be using the same name over here, V1. And the voltage source V1 is connected between two terminals. This is what input and it is what ground. So input, my positive terminal of my voltage source is connected with the input, and negative terminal is connected between the ground. So input and ground, and there will be a amplitude and there will be a frequency. The two we have to note it here. This is what peak amplitude. I want to give like a 3 voltage peak, means like peak to peak it will be 6 volts. So with the strength of 6 volts it can generate the output. So frequency I will be giving the notation of 1 kilo. So 1 kilohertz frequency that I wanted to generate. If I use the insert command, so with that insert command, so there will be a spice command which is generated, which will define the functionality of your voltage source V1. So V1, as it says, right, it will be connected between input, connected between connected between input and ground with the notation of sign. There will be a 0 DC and a 3 volts peak and 1 kilohertz peaking frequency. So this is how I can define my voltage source V1. So voltage source V1 is defined. So now I have to define like a voltage source V2 and V3. So V2 and V3, again like I have to use same command wizard. I will be using Control M, so that a command wizard will be opened. So across the command wizard, again I have to generate a voltage source itself. I have to generate a command for the voltage source. So I have to ask the wizard over here to generate a voltage source command. So I have to use like constant voltage source, because like I need a constant voltage source over here. V2 is the constant voltage source. I will be using a constant over here, constant voltage source over here. Will be having a source name V2. So we'll be having a source name is V2, and a positive terminal which is connected. Positive terminal is connected with the dx, and negative terminal is connected to the ground. And the DC value which I have the value of over here, it is 1 volt. I will be using the 1 volt, and I will be using a insert command. So automatically that command over here is generated. So V2 command is generated, that I will be mentioning over here. This will be a V2 voltage source will be in between D1, sorry, it will be in between dx and ground. It is connected in between dx and ground with the strength of 1 volt, so that is how I define my V2 voltage source. So now I wanted to define the V3 voltage source. Again I have to use the same process, control M, control wizard. I have to use like voltage source. I have to select like what kind of voltage source it is. If it is a constant, we have to select a constant, and I have to give the all the details. So this is for first time, and second time like you can do it. If you have a practice, like we can do the same thing. So I will be using that with the practice. What I do is, the name of the voltage source is V3. Which is connected between this is plus and this is minus. So connected between ground, the positive terminal is connected between ground, and negative terminal is connected between dy with the strength of 1 volt again. So let me use the same command over here. There will be a V3 voltage source which is connected between ground and dy with the strength of 1 volt. So even you write like volts also here, V1V also, it will not give any error, like it will be simulated. So that is how 3 voltage sources which we have in the circuit, right? We have generated a spice command for them. So now coming to these two, there will be two diodes. We have to generate a spice command for the two diodes. That is in the with the same process, where D1 diode I have to connect D1 diode we have to connect. So where in between positive terminal is connected between, this is what output, this is what output, the positive terminal is connected between output, negative terminal is connected between dx. So here this is the voltage source, it has to generate the voltage of 1 volt, and now this is the diode, it has to do some task. It's not like generating 1 volt, it will be having a proper functionality. So the functionality of the diode will be defined in the model file. This is what the model file which we kept it over here, we copied over here. So the model file which has the definition of the diode, and the functionality of the diode will be defined over here. So for that what I do is, whatever the model name we have it, that model name we have to copy it over here. So once we copy the model name over here, automatically what happening, so whatever the diode is connected between the output and dx will be doing the task and will be having the functionality as per the functionality defined in the model file. So let us do the same thing. Let's do the same thing. D1 is the diode which is connected between output, output, connected between output and connected between output and dx. Positive terminal is connected to the output, positive terminal is connected to, this is the positive terminal, this is the negative terminal, like anode and cathode. Anode is connected with the output, cathode is connected to the dx, connected with the dx, and will be having the functionality. So I have the functionality, I have copied already. This is what the model file defines the functionality of my diode. So let me copy it. So I'll be pasting it over here. Let me paste over here. So now what I do is, the functionality of the particular diode will be with the model name over here. Once I copy the model name over here, automatically the diode D1 will do the function, will do the particular task in between the two terminals as per the model name is mentioned. So if I mention another model name with another model file, so if that it is like 2, let us suppose. So if I define another model file over here, if I define another model file over here, if I define another model file over here with the name 2, so it will be some other process will be defined in this. So it will be doing as per that process. It will not consider the model file 1. So according to the model file, it will do his function. Yes. So in the similar way, what I do is, so I will be copying that another file, like I will be generating a spice command for D2 also, diode D2 also. So diode D2 also. So for diode D2 also. Now coming to the diode D2, so D2 is connected between, so dy, positive terminal is connected to the dy, and negative terminal is connected to the output. So positive terminal is connected to dy, and negative terminal is connected to the output. And this diode also will be doing the same task and will be having the same functionality how the D1 has. So that's why what I do is, I will be copying the same functionality over here by writing a same model name here. So let me do that. So D1 will be doing this one, and now coming to the D2, which is connected between, dy and output, will be having the same functionality. How, like the diode has the functionality defined in the model file, it will be doing the similar fashion. Yes. So as of now, we have generated a spice command for D1 and D2 also. So finally, we have to generate a spice command for R also. So resistor also. So now coming to the resistor R1, this is what label name of the resistor. This is what label name which we have it in the resistor. Any label name we can take it. It's not like R1 and anything. RX, if is the label name we want to prefer, we can take it. So RX or R1, I'll be taking a more label name for the resistor, and the resistor is connected between two terminals, input and output, which is connected between the input and output, and will be the strength of that. How do we define the strength of the voltage source? We have to define the strength of the resistor also. So let us suppose like 1000, it's like 1 kilo, right? We have to mention that 1 kilo is like 1000. So after that, the functionality of the resistor, how we have like functionality of the diode is represented over here in terms of model file. So we have to do the same thing. we have to do the same thing. So here, so model file for the resistor we have already. That model name of model file for the resistor we have it already. That same model file I will be using over here. And now what I do is, so whatever the functionality I need as per the functionality as the model name is defined, that we have to copy. So now R1 is the resistor which will be connected between the input and output, and will be having the strength of 1000 with strength of 1 kilo, and will be doing some task, will be doing some functionality, has functionality as per that, as per the model file says. So model file will say it will be some offering some resistance, it will be opposing the current flow, something will be mentioned over here. As per that it will be doing. So if it is like 1 kilo, it will be mentioned here that as per the 1 kilo ohm resistance it has to offer some resistance. If I mention like 2 kilo ohm, as per the 2 kilo ohms it has to offer some resistance. So what it has to do, it will be done as it is based on the functionality is defined in the model file. So that is how spice command is generated for the resistor also. So as of now, like there will be 6 components there in the electronic circuit. So we have generated like spice code for the 6 electronic components. So